dear student, this is Devansha from Engg Institute of Engineering and Technology. We have been learning the subject Basic Electrical Engineering, and we have been learning the chapter which is called AC circuits. In the previous section, we have already discussed about the phasor representation of AC signals. With this respect, now, if any AC signal, if we are going to apply to three basic components of electrical engineering, which is called resistor, inductor, and capacitor, we need to check the behavior of all these three basic components, right? So, with this terminology, we will start with the AC circuits, where my job is to apply AC signal to only resistive network. So basically, in this particular session, we have to apply AC signal to resistor, inductor, and capacitor individually, right? So, if you take resistor individual, that means it is called a purely resistive circuit. If you take inductor only the circuit, that means it is called a purely inductive circuit. And if you take capacitor only the circuit, it represents as the purely capacitive circuit. So the AC signal I am going to apply to a purely resistive circuit. Right. Before that, throughout this session, we are going to discuss about three theories, which is called a purely resistive AC circuit, purely inductive AC circuit, and third theory we define as a purely capacitive AC circuit. Right. So, in all these three theories, we have to discuss 3 points. All these 3 points are the common point. First, we have to find a relation between voltage and current. This is my point number 1, where we have to derive the equation of current because voltage equation is already given to you. So, in this respect, we have to find the relation between voltage and current and the phase difference between voltage and current. In point number 2, we have to discuss about the phasor diagram and waveform of AC circuit. And point number 3 is we have to calculate the power P, that is equal to V into I. So let's start first with the purely resistive circuit. So as here you can see, in this network there is only one resistance where we have applied Vt is equal to Vm sin omega t, right? Where Vt is equal to Vm sin omega t represents the AC voltage that we are only applying to the single resistance. That's why this circuit we define as a purely resistive circuit. Here my job, my aim is to find the behavior of resistance when you apply AC signal, right? So here you can find Vt is the applied voltage, here Vr is the voltage drop across the resistance, and Vm is the maximum value of applied voltage or maximum value of AC signal, right? So once you apply here for resistive circuit, so you can straight away apply Ohm's law, and from Ohm's law you can be able to find the value of current It is equal to Vt divided by R. So that is equal to Vm sin omega t divided by R. So I can represent this signal Im is equal to Vm divided by R. So from this I can be able to find the value of current It is equal to Im sin omega t. Now once you have a find the point number 1, where you have to find a relation of voltage and current, where V is equal to Vm sin omega t and I is equal to Im sin omega t, right? Now based on this you can say that here the phase difference between voltage and current is 0 because both the signals starts at angle 0, right? Because V is equal to Vm sin omega t and I is equal to Im sin omega t. So this is point number 1. Now let us discuss about point number 2, where we have to draw the phasor diagram and waveform. So let's first discuss about the waveform. Now you can see here in waveform where the x-axis represents the omega t and y-axis represents the amplitude of voltage and current. So that amplitude where we can show the maximum value of voltage and current as Vm and Im respectively. So here both the voltage and current start at angle 0. Why? Because the phase difference between voltage and current is at 0, right? So you can say here voltage and current are also in the phase, right? So you can see here sinusoidal signals start at angle 0 and this is a complete full cycle, and that complete cycle 2 pi, and that signal is continuously in repetition. So from this you can be able to say that from the phasor diagram, right, both the vectors of current and voltage start at angle 0, right? Here you can see both start at angle 0 and is rotating in an anti-clockwise direction. So this is a simple phasor diagram or phasor representation of voltage and current, right, for a purely resistive circuit. So I can say here voltage and current both are in a phase, and the phase difference is 0, right? The same statement we carry forward from our previous slide, where the phase difference of voltage and current is 0, so that Vt and It both start at equal 0. Right now, our point number 3 is the power calculation, where you can see here, if you are to find the instantaneous value of power, this is nothing but the multiplication of instantaneous values of voltage and current. So I can write P is equal to V into I. Right. So for V, I can use the equation Vm sin omega t, and for I can use the equation Im sin omega t. So from this, I can be able to write P is equal to Vm sin omega t into Im sin omega t. So again, P power P is equal to Vm into Im sin square omega t, and sin square omega t I can be able to write 1 minus cos 2 omega t divided by 2. Right. So here P is equal to Vm into Im in bracket 1 minus cos 2 omega t divided by 2. Now you expand this particular equation where power P is equal to Vm into Im divided by 2 minus Vm into Im divided by 2 into cos 2 omega t. Now we have total two terms. First term you define as a constant term, because first term is Vm Im divided by 2 minus the another term is Vm Im divided by 2 to cos 2 omega t. This term is the fluctuating term. Right. So if you take the average value of fluctuating term is always equal to 0. You must get some power dissipation across the resistance, and that power dissipation is nothing but P is equal to Vm into Im divided by 2. Right. Now let's take the integration of this power equation with respect to a complete full cycle, which is start from angle 0 and ends at the angle 2 pi or 360. So if I take the average value of this power, you can say P average is equal to integration from 0 to 2 pi Vm Im 1 minus cos 2 omega t divided by 2 of d omega t divided by the total interval is 2 pi. Once you take the integration of this complete term, you can be able to find P average is equal to Vm Im divided by 4 pi in bracket 2 pi minus 0 minus in bracket 0 minus 0. So once you solve this equation, you will get P average is equal to Vm Im by 2, and further you expand this equation, P average is equal to Vm by root 2 into Im by root 2. Now what is Vm by root 2 and Im by root 2? They are nothing but the RMS values of instantaneous voltage or RMS values of AC voltage and AC current. So finally you will be able to get P average value is nothing but the VRMS into IRMS. So it's nothing but V into I. Right. So you always remember there is a purely resistive circuit, there must be a power drop, there must be a power dissipation across a resistive circuit. Right. Now the same formula or the same terminology if you apply for the purely inductive circuit as well as purely capacitive circuit. Right. So far this is only a purely resistive circuit. Thank you, dear students. Let's start and discuss about the next topic, which is called a purely inductive circuit. Right. Again, the circuit where my first job is to now discuss about the purely inductive circuit. Now you can see in this particular circuit where there is only one inductor, and in that one inductor now we are applying AC signal. And that AC voltage signal is nothing but Vt is equal to Vm sin omega t. That is now applied to only inductor. That's why this is called a purely inductive circuit. Now once you apply AC signal to this inductor, right, across inductor there is a Faraday's law of electromagnetic induction, so that will induce back EMF, and that back EMF is represented as EB is equal to minus L into dI by dt. Induced EMF is nothing but the opposite direction of the applied force. So from this you can be able to find the back EMF but the in opposite direction of the applied force. So I can write here V T is equal equal to minus EB because it's in an opposite direction, right? So once I'm going to use this equation, EB is equal to minus L into dI by dt. So here Vt is equal to minus in bracket minus L into dI by dt. So Vt is equal to L into dI by dt. Right, now I'm rearranging this equation and taking the integration. You can see here the integration of di, because my job is to find current. 3 points. The first point we define as the relation of voltage and current. Again, here you have to also define the phase difference between voltage and current. Then draw the waveform and phasor diagram and the power calculation. P is equal to V into I. Find the value of current. We take the integration of di is equal to Vm by L integration of sine omega t into dt. From this, you can be able to find It, that is equal to minus Vm divided by omega L into cos omega t. Now here omega L is nothing but we define as the reactance of inductor, that is represented as 2 pi Fm, that we will see in a minute. So from this you can be able to find minus cos omega t. You can write the term like sin omega t minus 90. So once you go all equations stepwise, you can see here you can be able to find the last equation of current. It is equal to Im sin omega t minus 90. Right, from XL is equal to 2 pi FL or omega L, which is called reactance of inductor. Now here once you find the difference between voltage and current, you can see here V is equal to Vm sin omega t and I is equal to Im sin omega t minus 90. So here you can clearly see the phase difference between voltage and current is angle minus 90. So once you plot these two particular AC quantities, voltage and current starts after 90 angle with respect to that of the voltage. So here current start after 90 angle. So here current is lagging by angle 90 with respect to voltage, right? So that can you can see from this waveform where voltage start at angle 0 and current starts at angle 90, right? So from this you can also observe the phasor diagram when this voltage and current vectors are moving in an anti-clockwise direction. Well, voltage start at angle 0 and current starts at angle minus 90, right? So once both are having omega t, so the angular velocity of voltage and current are same, right? So this 90 angle is permanently maintained between this. So current is always lagging behind by, or current is lagging by angle 90 with respect to voltage. So here current It lags by angle 90 with respect to voltage Vt. So hence the phase difference between voltage and current is minus 90. Now our point number 3 is we can see the find the power calculation. P is equal to V into I, where Vm sin omega t into Im sin omega t minus 90. Now you convert into cos term, you can be able to find the power, instantaneous power. P is equal to minus Vm Im into sin 2 omega t. Now this is only one term. This is not case as the purely resistance. There are two terms. One term is a constant term, that is Vm Im by 2, and another term is Vm Im by 2 into cos omega t. Now that term is a fluctuating term. Here you get only a single term, and that single term is a fluctuating term since the value, the equation of power Pt here is equal to minus Vm into Im sin 2 omega t. Now this is a fluctuating term. So if you are taking the average value of power, P average, that is equal to integration from 0 to 2 pi minus Vm Im by 2 into sin 2 omega t divided by 2 pi into d omega t. You can be able to find since this is a fluctuating equation, so the P average is equal to Vm Im by 8 pi bracket in bracket cos 4 pi minus cos 0. So ultimately here the average value of power is equal to 0. Why? Because this is the reactive component. So average value of for instantaneous value of power for purely inductive circuit, that is equal to 0. This is the case for purely capacitive circuit. Again, it's a part of the AC circuit where you can see here AC sinusoidal signal is applied to purely capacitor, where V is equal to Vm sin omega t is applied to the the capacitor. So the charge being stored in a capacitor Q is equal to C into Vt, where Q is equal to, you can say Q is equal to C into Vm sin omega t, right? But three common points are there. Point number one, which is to find the relation between voltage and current, also find the relation of the phase difference between voltage and current. Point number two is nothing but to draw the phasor diagram and waveform. Point number three is a power calculation, right? With this respect, my first job is to find the equation of current IT. So that IT is nothing but dq by dt. Once I put the equation of charge being stored in a capacitor, in this particular equation you will find IT is equal to dc Vm sin omega t divided by dt. So you can find IT is equal to Vm divided by 1 by omega c into cos omega t, right? So 1 by omega c I can represent as the reactance of capacitor, and that is replaced by xc. So here IT is equal to Vm divided by xc into cos omega t, where I can take Im is equal to Vm divided by xc, and instead of cos omega t I can write sin omega t plus 90. So you can see my final equation of current IT is equal to Im sin omega t plus 90. So I can say here the difference between voltage and current at V is equal to Vm sin omega t and I is equal to Im sin omega t plus 90. So here the phase difference is plus 90. Right, you can define your reactance of capacitor Xc is equal to 1 by omega c, that is equal to 1 by 2 by fc. Right, now let's start and discuss the diagram and waveform of this purely capacitive circuit, where you can see here the voltage start at the angle 0, but before that current is already started at plus 90 degrees. So here I can say the current is ahead of angle 90 with respect to voltage, or I can say here current leads by angle 90 with respect to voltage V. Same thing if you can observe using the phasor diagram, when voltage starts at the angle 0, but before that current is already started at plus 90 angle, where these two vectors voltage and current are moving in an anti-clockwise direction with the same angular velocity. So here current is always ahead of angle 90 with respect to voltage V. So you can see here current IT leads by angle 90 with respect to voltage Vt, right? So here the phase difference is plus 90. The power calculation P. Now for the power calculation P is equal to V into I. So once you write P is equal to Vm sin omega t into Im sin omega t plus 90, and then you convert into cos omega t. So then you will find the final equation P of t is equal to 2 Vm Im into sin omega t into cos omega t divided by 2. So from this you can be able to write the power equation Pt is equal to Vm Im divided by 2 into sin 2 omega t. Now you can observe this equation. Now this particular equation is nothing but the fluctuating equation. So average value of this power is always equal to 0, right? Now this is not the case with the purely resistive circuit, where in purely resistive circuit you will find total two terms. One term is a constant and another term is a fluctuating. Same way in a purely inductive circuit, Pt is equal to minus Vm Im by 2 into sin 2 omega t, which is the fluctuating sum. So average value is equal to 0. So here same way for purely inductive circuit you will find Pt is equal to Vm Im by 2 into sin 2 omega t. Once you are taking the integration of this term with respect to the full cycle 0 to 2 pi, you can be able to find the P average value Vm Im by 8 pi into in bracket minus cos 4 pi plus cos 0. So here average value of instantaneous power P average is always equal to 0 for purely capacitive circuit, right? So here we have discussed the three individual circuitry: purely resistive, purely capacitive, purely inductive, where you need to understand total these 3 points. Like first point is, if you are a purely resistive circuit, the phase difference is 0. For purely inductive circuit, phase difference is minus 90. Purely capacitive circuit, the phase difference is plus 90, right? So for first case, for purely resistive case, voltage and current are in phase. For second case, purely inductive circuit, current leads by angle 90 with respect to voltage. For purely capacitive circuit, current leads by angle 90 with respect to voltage. And for first case, the purely resistive case, the power you will get the constant power P is equal to Vm Im by 2, that is Vm by root 2 into Im by root 2. So that average value of power is equal to Vrms into Irms. But this is not case for the purely inductive and purely capacitive circuit. For the average power of for both the circuit, purely capacitive and purely inductive, average power is equal to 0. Thank you, dear students. If you have any doubt, please write in the comment box.